Example 5. Use the vectors illustrated in the figure to graph the vector 2 times u minus 3 times v plus w. All right, so this particular problem has all three operations going on. We're adding, we're subtracting, and performing scalar multiplication. We always need to follow the order of operations, so we will start inside the parentheses. So inside the parentheses, we have 2 times u minus 3 times v. That is the same thing as 2 times u plus negative 3v. Okay, so that's how we need to look at it. So the first vector we are going to graph is 2 times u. Okay, so I'm going to start way over here on the right side because we are adding negative 3v. Okay, and v is going to be quite long if we triple it. I already made this video one time and didn't put it in the right place, so I've had to redo it. So we are starting on the right side to make this thing fit. Okay, so I'll start 2u off right here. Okay, so this point right here, and we're going to go, if you look at u, to form u, you need to go down 1, right 2. So down 1, right 2, so that's going to be this point. But we're doubling u, so we need to double its magnitude. 2 is positive, so it's going to keep the same direction, but we do need to double the magnitude. So we need a second copy of u. So we already went down 1, right 2. We need to do it again. So down 1, right 2. Okay, so now this is 2 times u. Okay, so we're going to connect our initial point to our terminal point. Okay, so this is going to be, like I said, 2 times u. Okay, now we need to add to this negative 3 times v. Okay, so what that means is we are going to have to triple v in length, and we're going to have to change its direction because of the negative sign. Okay, so we've looked at v before. We know that to go from the initial point to the terminal point, that's 1, 2, 3, 4, 5 units. Okay, so normally we would be going to the right, but since we're changing the direction, we're going to be going to the left. And instead of 5 units, we're going to triple that, and we're going to go 15 units to the left. Okay, so since we're adding these guys and I'm using method 1, the initial point will coincide with the terminal point of 2 times u. So this is the initial point, and we're going to go to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that is where we're going to end up. Okay, so here we go. And this is the terminal point, so the arrowhead will be right here. Okay, so this is going to be negative 3v. Okay, if we want to add them together to get that resultant, then that is going to be the vector drawn from the terminal point, or sorry, it's drawn from the initial point of the first vector to the terminal point of the second vector. Okay, so it's going to be drawn like this. Okay, so it's going from the initial point of 2u to the terminal point of negative 3v. So this black vector is going to be 2u minus 3v. Okay, now we need to add w to this. Okay, so we're going to now focus on the black vector. The black vector is 2u minus 3v. We have to add w. Okay, we already know that for 2u minus 3w, this is the initial point right here. This is the terminal point, okay, right here. Okay, and so what we will do is this terminal point of w, or sorry, this terminal point of 2u minus 3v, that is going to be the initial point of w. Okay, so right here where this black dot is, this is going to be the initial point. Okay, to form w, we need to go to the right 2 and up 5. Okay, so we will do that here. So from this green point, we will go right 2, up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this will be the terminal point of w. So we will connect, okay, the initial point to the terminal point. Okay, so here's the arrow on the terminal point. This is w. Okay, this black vector is the 2u minus 3v. okay? And so now we need to draw in the final answer. Okay, so let me pick a good color for this. I'll use orange, okay, so it stands out, okay? So for the final answer here, okay, we're adding the black vector and the green vector, okay? So its initial point will coincide with the initial point of its initial point will coincide with the initial point of the first vector, okay? And its terminal point will coincide with the terminal point of the second vector. Okay, so we will draw from this orange point to this orange point, and the arrowhead will be on the terminal point. Okay, so this orange vector right here is the final answer, 2u minus 3v plus w. Okay, so that was a great example of using all the operations in one problem.